If you've been watching my channel for a while, you probably already know that I studied aerospace engineering at university, but now I'm working as a software engineer. I taught myself how to code primarily by myself with minimal official education. Okay, so I did study computer science at GCSE and AS level. However, I do think that majority of my understanding in software engineering has been self-taught. One of the biggest problems with being a self-taught software engineer is because there are, quite a few big gaps in your knowledge. Okay, not everyone's gonna have these same gaps. Other people might have gaps in other areas, but in this video, I'm just gonna cover what I hadn't learned whilst I was studying in school or university and learning about software engineering on the side. The thing with going and learning how to program through boot camps or university, you have someone in essence telling you what you need to learn, so you don't miss out on any of the main core important things you need to know to become a really good software engineer. But if you are learning how to code yourself, you don't know what you need to learn. So that's one of the hardest things about being a self-taught software engineer. And I'd say that there will be gaps in your knowledge. And hopefully this video will show you what you should be learning to be a great software engineer. The first thing I wish I did learn earlier in my journey of becoming a software engineer are the more advanced data structures. Because I'm sure most people, when they're learning how to code, you get familiar with how to use an array, and that's probably like the main data structure you really get to play with. But when you start to understand more about data structures and understand the more complex ones, for example, things like stacks, heaps, linked lists, hash tables, queues, and trees, if you start to learn all of those, then when you're working on creating a solution, you're gonna be able to write a more efficient piece of code. The second thing I wish I'd learned earlier were algorithms. And I'm not talking about, like what is an algorithm? I'm not on about like being able to answer that, but what I'm talking about is understanding well thought out algorithms that you can just apply in different scenarios and have the best solution there and then when you code it up. So some of the algorithms I'm referring to are things like depth first search, breadth first search, and these are great for being able to traverse trees. Other algorithms that you can also learn which would be helpful are your sorting algorithms like quick sort, bubble sort. Actually, if you've ever done discrete or decision maths in A-levels or schools, wherever you are, I don't know which country you're from, so whether you do A-levels or not, but if you've done something related to decision maths or discrete maths, you've probably come across these types of algorithms before. Because when I did decision maths in sixth form, I remember learning about packing algorithms, sorting algorithms, and other algorithms such as Dijkstra's, I think that's how you pronounce it, Dijkstra's root finding algorithm. So yeah, ultimately you can even learn algorithms in your maths subjects if you've done decision or discrete math. The last thing I wish I learned earlier was to truly grasp the big O notation. The big O notation is all related to understanding the time complexity and the space complexity of a piece of code. In an ideal case, for any piece of code, you want the time it takes to execute the code and the memory needed to be allocated to perform the calculations within that piece of code to be constant regardless of the size of the input into that piece of code. However, this can't always be done, so you have to understand, what's the best way you can write a piece of code to ensure you do minimize the effect of the input size growing. So, you don't want it to grow exponentially, because if it takes exponentially longer to compute something depending on how big your input is, then that's really, really bad if you want your code to be, able to scale. So it's really useful to understand your big O notation because it helps you understand how efficient and how scalable your code really is. So just to recap, there were three things that I did wish to learn earlier, which was advanced data structures, algorithms, and the big O notation. But maybe you're wondering, but Saga, how did you end up going about learning them, and how should I, like as in you, not I, but you, begin to learning them yourself? The best way, in my opinion, to learning these sort of things is to go on websites like LeetCode and HackerRank and just practice doing the problems in those websites, because those types of websites are able to work on different problems and create solutions and trying to get the most efficient solution. And by just practicing these questions, you start to learn, okay, these are the types of algorithms I need to use with this type of question. And then you also will pick up techniques that you weren't aware of before. But the good thing about using these websites is that there's plenty of solutions online. So if you do get stuck, it's really easy to find out how to, actually solve the question. And from that, you can then learn about, okay, I need to use this type of algorithm for this sort of question. I should use these types of data structures for this sort of question. And then you slowly start to understand and piece together, okay, this is the type of algorithm for this type of problem and so on. So it's really great and, kind of like an iterative process we just have to do, but I'd say it really ingrained in your brain about how to use these sort of data structures and understand the complexities and algorithms related to solving these problems. If you learned something new from this video, consider subscribing and like the video, and also I will see you in another video. If you want to check out a video on what I'm currently doing at work, you can check this video out. It's over somewhere, it will appear wherever, but click on it and enjoy. See you around.